Hello guys, welcome back. Today we are going to understand Leetcode 200 question, and these questions belongs to number of islands we have to find, right? So we'll see the question how we will going to solve these questions, right? So first of all, we have given m cross n 2D grid, right? You can set matrix which represent a map of 1s, and we call this as a land, and zeros, right, it's a water, right, and return the number of islands, right? So an island is surrounded by water, right, that is once, right, and is formed by connecting adjacent lands horizontally or vertically, right? We have given another statement saying you may assume all the four edges uh, right of the grid are surrounded by water, right? All the grids, let's suppose what does mean is all the four grid, suppose this is the grid, right, and we have given this one, right? So it is saying that these four grids are surrounded with water, means these are having 0 0 0 0 0 like this we have given, right, like this. Okay, all are 0, and between that what we have, either it's land or it's you can say a water, right? So these things you have to understand before understanding these questions, right? Coming back to the problem, right, we have given what, we have given lands and water in the grid, and we have to return the number of islands. So how will you find the number of islands, right? So this is another example, right? Let's assume what I'm talking about. So we have given here you can say grid, right? So this grid, if you'll represent this one, so all the ones here in this example one is what we have, one, like it is going on, right? That's why we are collecting all this one, and there is these all ones are surrounded with water, that is 0 0. Even the boundaries contains 0, right? As you know, we have to assume actually, right? So this is nothing but your lands, right? Like this, got it? Okay, so number of output is number of island is 1. Okay, now coming back to example 2, in which we can see we have given two things, right? First we have given grid, right, and in which we have given all ones. So this is 1, this is 1, and this is 1, and this is 1, right? So if we'll collect this all, and this is surrounded with waters, right? So we can say this is one, this is one island, and this is one another island, and this is another island, right? And that's why total number of island is 3. So how we will going to use this, right? So what we will do, we will assume this all the grid, right, as a root of the value. So for the first element in this cell, we can say this is the root element, right? So we'll start from this root, and it will start traversing. So you can see the blue color we have marked, this is your first island, right? Similarly the green one become second island, and the third one, yellow color, is the third island, right? So if you calculate all these, so number of island now become is what, 3. Okay, in this example. Okay, so the first approach we are going to discuss today is DFS, right? Why? Because DFS is a very good approach and easily can be explained, and you can do, right, in the interview room. So firstly, let's understand we are going with the initial grid map, right? So we'll start with this one, then we will move to this one, and then we'll move to this one, right, in all these directions, right? So you will follow this approach, right? Let's continue. First of all, we'll see that this is your root node that triggers DFS. So we'll start the first cell, right, and then we will move to the next, and next in all the directions, right? So this is the first directions in which we will move like this, right? And if you'll find one, then this is your, you can say, land, right? Otherwise this is water as a 0. So we'll move to the next one. After traversing the elements, right, we'll reach to here, and we'll count this one as a second island, and further we'll move to the next one and we'll say this is also a new island, right? So now we are done, and we can say that total number of islands is 3. And let's continue to understand. So what exactly we are doing actually, right? So let's suppose firstly we are traversing like this, right? So this is the first cell, right? I'm just assuming it, right? Let's suppose this is the first any cell we have, and this is nothing but you can say this is a cell, right? So if you'll talk about the row, right? And so how many directions we have to move, right? So for the row, either we'll move to these directions, right? Either this direction, right? Only 2 directions we can move. And this is, you can say, if this is this is nothing but your R. Let's suppose this is R, means this cell, let's suppose I have not mentioned, so this cell will become what? This is become R minus 1, correct? Sorry, R plus 1. This will become R plus, no, correct. This is R minus 1 only. Let me say this is R minus 1, because we are uplifting, right? We are uplifting, and when we are going to here, this will become R plus 1. Okay, so if someone is coming in this this row, this is R plus 1, and if going up, R minus 1, correct? Next, let's assume if this is the first column, if this is a column, right? We are talking about if this is a column, right? So what will happen if we want to move to here, next column? It means if this is C, right, this will become what? C plus 1, right? And that's why we'll come to here as another cell, right? Another column, right? And so that when we come to back, right, here like this in this direction, so what will happen? This will become what? If we're coming to this direction, this will become C minus 1, right? So now you can assume that if I will map this, right, so it will look like how? Like this only, right? So I am connecting all these, right, actually like this, and so this will become like this. Okay, so this will become your a grid, correct? So for each element you have to understand, for incrementing row and incrementing column, you will have to move like this, right? Either you coming to this direction or this direction. Okay, I think you got it. Okay, so first of all, what we have to understand here is we have given this function, right? Find number of islands, right? And we have to return the integer, right? So we are passing this grid. We'll check if grid is null or length is 0, means we don't have to do anything. We'll return 0, number of island is 0. Otherwise we'll count row and column, right? And number of island, the third variable, and we will move to all the row, right? These all rows, we will go to all these rows, right? R plus 1 like this, right? So it will start from what? R0, and it will move to what? NR, correct? So what will happen? R will start from 0 and it will go to NR and R plus plus, and we have in this direction if we'll go, right? So it will become what? Column C0 to NC, right? Will go. So it is going there. Now we'll check these conditions, right? If row and column is 1, let's suppose if we are talking about this one, okay, if this element contains what? 1, it means what? Number of island is what? Incremented, plus, right? Now is become from 0, there is, if all these are 0, let's suppose these all are 0, okay, and only one element, this one is 1, right? It means number of island is what? Island is 1, because now it is incremented. Previously it was 0, so we have to plus, right? Now this will check in all these directions, right? This will check in all these directions, okay, as you know, right? See, r1, r1, r minus 1, r plus 1, c minus 1, c plus 1, right? That we are going to discuss, right? So what we have to understand, let me clean this one. Okay, coming back to this position, right? Now we are going DFS. So we were talking about if the grid contains 1, right? If the grid contains 1, we will either move to this direction, this direction, this direction, or this direction, right? All these 4 directions we have to move. That's why we are passing grid R and C for this row and column for this index, because this is assuming R and C. So what will happen, we will create one DFS in which we are passing grid R, C. Similarly, we'll find number of row and column for this, and we'll check all these boundaries. If row should not be less than 0, column should not be less than 0, R should not be greater than NR, C should not be greater than NR, NC, and its value should not be equal to 0, means it should not be the water, it should be land. If these are not matching, right, and it's moving to the boundaries, right, we are returning the control. Okay, otherwise very simple things you have to do is you can check grid R and C, right? You will check the grid R and C. If actually we have to mark this as a 0, right? Now this will become what? 0, right? And then we'll move to these all directions, we will move, right, one by one. So firstly, let's suppose we are going to this direction, okay? R minus 1 means we are going to this direction, right? We will check at this position, right? If this position contains some element, right, at this, right, because column is same, right? Column is same, but we are going to this row, right? So that's why it become R minus, because previously it was R, so now it is what? R minus 1, right? Means we are talking about this direction. Then here we will check. Similarly, if we find this one, what? 1. Let's suppose we find 1. Now we are calculating the same things, right? That what will happen, we are calling DFS, right? If this is the thing, if this is 1, we will mark this as a 0, right? Similarly, if this is 1, we'll move to this direction, this direction, R plus 1, right? So we'll check if this is 1, we'll mark at a 0. If this is 1, we will mark at a 0. If this is 1, like this 4 direction will go, and we'll mark this as a 0. So now all is become 0, okay? So initially value you have to mark, right? Otherwise it will not work, okay? Now all these 4 direction, right, as you can see. So if this is a grid, right, it's if we have started with the 1, let's suppose it started with the 1, means now it is 0, right? And as well as these neighbors are also becoming 0, as you can see, right? These cells are becoming 0. Only this one will not, we are not going to traverse, and this one will not going to traverse, right? This corner case we are not going to do, right? Otherwise these 4 will become 0, we have to mark. Next we are going to move to the next grid, right? Let's suppose the element that we are talking about here, this one. So let's suppose initially what happened here, let me move to here, okay? So what will happen, initially we are going to traverse this one, right? So we'll move this direction, right? So this direction, now what will happen, we are coming to this position. Now initially we saw 1, so number of island initial was 0, so from 0 we have become 1, right? Now this is, we are going to DFS, right? So DFS, in the DFS what we'll check the boundaries. If boundaries is okay, we are marking this as a 0, right? Similarly we'll move to here, the DFS of the next boundary. Now we are going to do what? Boundaries we are making at a 0. Similarly we'll mark this one as a 0. Similarly this will mark at a 0, like, right? Because see, all these conditions is happening what? We are going to the DFS and we are marking the row and column as 0, right? And similarly with the 4 directions, right, that we are talking about. So this will become 0 initially, right? And it's all these 4 neighbors is also become 0, right? So this will happen. So now this will look like how it will look like. Now the grid contains 0 0 0 0 0 0 1 0 0 1 0 1. So this will look like this one, right? So guys, if you have any doubt, you can ping me in the comment box, okay? So don't hesitate and anything, okay? Let's come back to here. Now this is remaining same. Similarly, we have the for loop, right? So we'll continue this for loop, right? Now from 0 to 0, right? We are moving, R will become what? The next row, right? We have first moved to all the rows, right? Initially, now we will go to R1. Like this we will continue, so that we will go to the next level, right? So once we will reach at this position, we will find again 1, means this line of code will work again, right? Means number of island is now incrementing to what? Number of island is now 1 to 2, right? Number of increment. So when we will reach to here, or you can say here, right? What will be now? It is 0. So it will go to these directions, it will check it's already 0. Now this will come to down, right? R minus 1 and C. So when it is coming to R minus C, so R minus 1 and C, we'll see the data here, right? And number count will become what? 2. Now we are coming back to this position, as you can see, okay? When we reach here, number of count will become to what? 2 to 3. And all neighbors are zeros. We are not going to do the DFS, right? We will just mark the simple things here as a 0, because there is only one times. So what will happen, the first time it will come, it will mark that 0, and rest we are not going to move, because there is all neighbors are 0, right? So that's why finally we will get number of count is 3, right? And we will return it, right? So this is all we have in this video, right? And if we'll talk about the complexity thing, right? So time complexity, if we are if you think that m is the number of rows and n is the number of columns, so we are moving to all the row and column, because we have the matrix, right? And in the matrix all cells are be traversing, right? If there is 3 row 3 column, right? 3 row and 3 column, we are going to 9 times, right? So time complexity will look like this one, m cross n. For the space, we are storing all the elements, right? And in the worst case, right, grid is filled with all with the lands, and in the worst case it will become O of m into n, right? This approach can be done by the BFS, right? You can pause this video, it look like similar. No, you don't have to do anything, right? Rather than what we will do, you will make the condition, right? We'll have those values on the for loop, right? You can move to this for loop, you can check if it is 1, you mark it as a visited. You can move to the neighbor queue, right? You will make a queue and will move to the neighbor, right? And similarly we'll check all these conditions, right? And if this is working, then we can do. So pause this video and do, and we'll see you the next lecture with the second approach, BFS. Thank you guys, thank you for watching this video.